Okay, so we're ready to see how the whole statistical test would happen. All right, so let's go through these steps here. After stating the null and alternative hypotheses and specifying the level of significance, a random sample is taken from the population and sample statistics are calculated. All right, so this is the part where we're taking the sample and we're going to use it to test these hypotheses. All right, so the statistic that is compared with the parameter in the null hypothesis is called the test statistic. All right, so mostly we're going to be using mu, but we might use a population proportion, p, or something like that. But for the most part, we're going to be looking at the mean mu. With the assumption that the null hypothesis is true, the test statistic is then converted to a standardized test statistic such as z or t. And then we're going to use that to make the decision about the null hypothesis. So just like before, we're going to be deciding whether to use z or t based on certain information in the problem, and we're going to use that standardized test statistic to check and make our conclusions. So again, as we're going to do most, if we're looking at the population parameter mu, and we're using x bar as our test statistic, we're going to use the normal z if sigma is known, the population standard deviation, or t if sigma is unknown. So just like when we were doing in the confidence intervals, the same applies. So that's how we're going to decide. So when we go into section 7.2, we'll see how we do this with the z values, the normal distribution, and then 7.3 we'll see how we do it with the t distribution if we don't actually know sigma. Okay, so more about how this gets carried out. So when I say that we're going to use the z value or the t value to test the hypothesis, what are we saying? Well, we're going to use that to determine a p-value, standing for probability value. This p-value is what's going to tell us whether we should reject the null hypothesis or fail to reject. So it really is comparing, it's attempting to compare the sample we got with what we think, how representative it is of the actual distribution. And we'll see that as we move along a little better. So there are 3 different types of tests that we carry out. They're all done in a similar way, but with slight details of how we use the p-value, or get or use the p-value. There's the left-tailed test, the right-tailed test, and the two-tailed test. Okay, and this is determined by the area, the region of the sampling distribution that favors a rejection of H0. All right, so, and this is the region corresponding to HA, the alternative hypothesis. So let's take a look at each one of these. All right, so the key here is that to determine which test you're doing, look at the alternative hypothesis HA. All right. If it's a less than in the alternative hypothesis, just like here, so here's where I'm looking, mu less than k, we'd be talking about, just like we did, with the z-tests, with the z lookups, we'd be talking about an area to the left of our standardized test statistic. So this area in here, all right? So that's going to tell us, so the alternative being mu less than some value is giving us the left-tailed test. If the alternative hypothesis had a greater than, then we'd be talking about a region that was greater than the standardized test statistic, so we'd be talking right-tailed. And this is where we have to make sure, we make our adjustments based on the scores and what values we're getting because of the default that we get areas and probabilities to the left, so we have to watch out for that. And then the two-tailed test. If the alternative is a not equals to, then, just like we're looking right there, then we have to break it. So what we're saying by not equals to is we're saying there's a whole region in the middle of the equals to, and then the not equals to is now split in two with half of the probability there and half of the probability there. So that's the two-tailed test. All right, for example, here we're going to state the null hypothesis and the alternative hypothesis. We can identify the claim, and then we're going to talk about whether it's left-tailed, right-tailed, or two-tailed, and we'll shade the area for the p-value. So these are the examples we looked at before, so I'm going to go through the hypotheses a little quickly. All right, so this one before was the proportion equal to 61%. So we had H naught as P equals 0.61, and the alternative was P not equal to 0.61, and this happened to be the claim here. And again, the null hypothesis had the equals in it, the alternative does not. All right, so in this case, it's an equals not equals, which means that what we're talking about is we're talking about a two-tailed test. We're talking about the not equals being on the left and right side. So this is two-tailed. And this area here is 1/2 p. Okay, so I'm overusing p's here. The p in the hypotheses is the proportion. This p is the probability value. So it's a little bit of an overuse of p. All right. Car dealership announces the mean time for an oil change is less than 15 minutes. Okay, again, that says mu less than 15, which would have to be the alternative. Mu greater than or equal to 15 would be the null. And then this was the claim here. So look at the alternative. The alternative says mu less than 15. So that would correspond to an area over here. And so this would be a left-tailed test. And this would be the area P. Okay. Mean life of furnaces more than 18. Again, this would be mu greater than 18, which doesn't have an equality in it, so that has to be the alternative. The null would then be the rest of it, u less than or equal to 18. Oh, and this was the claim here, the alternative. Okay, and now the alternative says mu greater than. That would correspond to an area greater than some value, and so this would be right-tailed. And there's your P area.